Okay, this is Paul Geyer, and I will be the presenter today for this PDH Source webinar, An Introduction to Anti-Terrorism Standards for Design of Buildings. If any of you can't hear me on the audio, let me know. I will assume that you can all hear if I don't get any messages from you to the contrary. So here we go, an introduction to anti-terrorism standards for design of buildings. Let me get my controls moving here. This is kind of the chapters in the book, if you will, what I'll be talking about today. Assumptions, baseline threats, controlled perimeters, and access control. Something strange is happening with my controls. For some reason, the slides are being advanced when I don't want them to advance. Anyway, this is kind of what I'll be talking about today. The chapters in the book, if you will. Now, and here, for what it's worth, is a little bit about me and what I've been doing for the last few decades in kind of my career number 2 when I had my own architectural engineering firm. Why we did a lot of building design and facility design for the military, for the Department of Defense. And so we got fairly familiar with design for, in kind of a hostile environment. And of course, as we've seen in the last decade or so, this has become more and more of an issue. This discussion today is I will make reference from time to time, I suppose, to quote, government buildings and facilities. But the same thing applies to non-government ones. The government ones, of course, because that's the in many, many cases, if not the vast majority of cases, the target of terrorists is some kind of a government facility and military in particular. So this is what I'll be talking about today. Now, again, you're going to have to bear with me. I don't use this particular presentation system terribly often, so I'm not as familiar with the controls as I would like to be. Okay, so here we go. Let me see, gosh darn it, why are my slides changing when I don't want them to change? Okay, so what's the threat? Location, size, and nature of terrorist threats are, of course, unpredictable. And the standards discussed here are based on a range of assumed threats that provides a reasonable baseline design for the design of buildings and related facilities. And it will give a general level of protection today and establish a basis upon which to build additional measures where they are justified by higher threats or where the threat environment increases in the future. Well, the baseline threats discussed here are less than some of the terrorist attacks that have been directed in recent decades against U.S. personnel. They represent more severe threats than a majority of historical attacks. It would be obviously cost prohibitive to provide. Gee, I wish my slides would stop moving without my doing anything. It would be cost prohibitive to provide protection against the worst case scenarios. And the threats that are discussed here are assumed to be directed against personnel, not something else. And the following are the terrorist tactics upon which these standards are based. So, explosives, the baseline explosive weights are identified in tables B1 and D1, which come at the end of this discussion. By the way, you may possibly like to have a copy of these PowerPoints that we'll be looking at today. And I'm pretty sure, can get them from PDH source. Gosh, I wish my slides would stop doing that. I think you can get a copy of these PowerPoints from PDH source probably by going online and logging into your account and following the instructions, and they may be of some interest to you moving forward. Now, the method of delivering the explosive is, first of all, one is vehicle bombs. And they are assumed to be stationary vehicle bombs. These standards are based on a stationary vehicle bomb. Somebody drives up, parks a car or a truck in front of a building, and then runs away. They're not based on someone in a vehicle driving 90 miles an hour straight through the protective barriers and that sort of thing. And so the assumption here is that the aggressors want to park the vehicles covertly without being noticed as doing anything unusual. And it is assumed they will park in legal parking spaces or areas. The sizes of the explosive in the vehicle bombs associated with explosive weight are likely to be detected in a vehicle during a search. So the vehicles do not, the drivers of the vehicles do not want to go through a checkpoint. Okay. So the explosive weight is the basis for the standoff distances associated with a controlled perimeter or situations in which there is no controlled perimeter. Standoff distance, the perimeter, in other words, you are implementing measures to see that people do not approach a building without going through a checkpoint. That's the perimeter, how far away you keep them. And the quantity of explosives associated with explosive weights is, it's assumed to be able to enter a controlled perimeter undetected. Therefore, the explosive weight is the basis for the standoff distances. So the a second threat is waterborne vessel bombs. And gosh, I wish these slides would stop moving without my telling them to. So, first of all, there's the vehicle threat, a car or a truck driving up to a facility, parking it, and then detonating the explosive. A second category is waterborne vessel bombs. This is a threat for in harbors and things like that. Obviously, a boat drives up adjacent to a typically another ship or something like that, and detonates the bomb. And for waterborne vessels, they are assumed for purposes of this discussion here to contain quantities of explosives associated with either explosive weight 1 or 2, which you will see in these tables at the end of this discussion. And depending on whether or not a controlled perimeter has been established. The third category is placed bombs. These are hand-carried explosives placed near buildings that can cause, obviously, significant localized damage, resulting in injuries and fatalities. It's assumed in this discussion that aggressors will not attempt to place explosive devices in areas near buildings where those devices could be visually detected by building occupants casually observing the area around the building within the unobstructed view. And explosive weight 2, which you will see in these later tables, is assumed to be placed by hand either in trash containers or in the immediate vicinities of buildings. That quantity of explosives is further assumed to be built into a bomb 6 inches or greater in height. So a placed bomb is one that someone hand carries and it is placed in some kind of a concealed location in a trash container or something like that. It's not just left sitting in a hallway or something like that. So that's an assumption of this discussion. Mail bombs. They, of course, are explosives in packages delivered through the mail, and they can cause significant localized damage, injuries, and fatalities if they detonate inside a building. And no assumption as to the size of such explosives is made in these standards. So these standards do not make any assumptions about the size of a mail bomb. Provisions for mail bombs are limited to specifying the locations of mail rooms so that they can be more efficiently hardened if a specific threat of a mail bomb is identified in the future. They only apply, these standards only apply to expeditionary environments. Now, the word expeditionary means when a military contingent leaves the United States and goes to another country, to a hostile environment. So that's what that term means. And as I indicated at the start here, a lot of the nomenclature here has a military tone to it because that's where the greatest number of terrorist attacks have materialized in recent decades. But these same provisions would provide, would be applicable to civilian facilities that are threatened. And indirect fire method weapons, these are assumed to be things like military mortars with fragmentation rounds containing explosives equivalent to explosive weight 3, which you will see in table D1. And these tables are at the end of the discussion here. Direct fire weapons, These are small arms weapons, shoulder-fired rockets that require direct lines of sight. And some standards in this discussion are predicated on a direct fire weapon threat. Provisions of these standards are based on the assumption that those weapons will be fired from vantage points outside the control of an installation or facility, outside the secured perimeter. Obscuring or screening that minimizes targeting opportunities and mass notification of the occupants in the facility is assumed to be the primary means of protecting personnel from these weapons, direct fire weapons, in this discussion. And hardening to resist direct fire effects represents excuse me, a higher level of protection than is required by these standards. So these standards, which we will be getting into, are not intended to protect against direct fire weapons. The protection of personnel is based on obscuring lines of sight from vantage points from which a weapon could be fired, and then to provide mass notification. That means a public address system that says we're under attack, leave this building. And then the next category of threats is the chemical, biological, and radiological weapons. And for purposes of this discussion, those weapons are assumed to be improvised weapons, not something that's made, manufactured within a country's military environment or something like that. They're improvised, and they are assumed to contain airborne agents employed by terrorists. I apologize for this flickering of these slides, and I don't know why they are doing that, but they're moving when I don't want them to move. These standards in discussion here do not assume comprehensive protection against this kind of threat. They provide a means to reduce the potential for widespread dissemination of such agents throughout buildings in the event of an attack, either outside buildings or in mail rooms. Okay, now controlled perimeters and access control. And these are two primary concepts in anti-terrorism protection, is establishing a controlled perimeter. In other words, that you do not allow people to, or vehicles to come within a certain distance of the facility without passing through a checkpoint, where they can be checked to see if the vehicle or the person has an explosive. And so the concept of controlled perimeters and access control are fundamental to the discussion we're having here today. And you will see later as we move forward the recommended distances. Now, let me back up for just a minute here. This wrestling with these controls is driving me a little bit nuts. One thing I don't think I mentioned at the start is the schedule for this chat. In other words, how we move forward. And the way we do it here at PDH Source is I move forward with the discussion, and for for 50 minutes and then take a 10-minute break so people can check their email or whatever they want to do, come back, do another 50 minutes, 10 minutes, 50 minutes, 10 minutes. Now this is just a PDH or 2-hour discussion, and so we'll just go through that cycle 2 times. Okay, so now we're moving into a discussion of the controlled perimeters and access control. And the standards discussed here assume that procedures are implemented to search for and detect explosives. So it's important to keep in mind the need for procedures. You can have a facility that has all of the proper anti-terrorism physical features incorporated into its design and construction. But if the people there are not using the right procedures, then the security is going to be compromised. And right procedures can just be things like when someone comes through an access point, and if they don't work at the facility and have their own appropriate badge attached, a procedure is that once you have, if you will, search them and search their vehicle, you then give them a badge with a V on it that means visitors. So when they're walking around, people know that that person is not someone who is routinely working or present in that facility. And so procedures are important, and they are implemented to search for and detect explosives, to limit the likelihood that a vehicle or a person carrying quantities of explosives equivalent to explosive weight 1. And I keep referring here to explosive weight 1 and explosive weight 2, and you will see what these are when we get to tables B1 and D1, and that they could penetrate a controlled perimeter undetected. It's further assumed in this discussion that access control will include provisions to reject vehicles without penetrating the controlled perimeter. In other words, that they are stopped at the access control point. You don't let them get beyond the controlled perimeter and then have to go chasing after them and eject them from inside the perimeter. So the question of these access control measures and procedures are beyond the scope of what we're talking about here. We're talking about here just the design of the building, standoff distances, and controlled perimeters and access points. Vehicle barriers, the assumptions in these standards, what we're talking about today, are predicated on a stationary vehicle bomb threat. And the vehicle barriers that are described in this discussion are not intended and not required to stop moving vehicles. Again, this is based on unfortunate experience where the vast majority of terrorist acts have involved a stationary vehicle. Drive up to the front of the building, park it, run away, and then the explosive gets detonated. But this discussion does not cover a terrorist who is driving a truck at 90 miles an hour and crashes through a fence or anything like that, because experience has shown that that kind of a threat is not that common. So the the controlled perimeters that are described in this discussion, and you will see the sketches of the recommended controlled perimeters further on in this discussion. The perimeter barriers are not required for controlled perimeters. In other words, they're not mandatory that you have constructed walls or fences or things like that. Often you do, but the controlled perimeters require physical boundaries that channel vehicles to the access control points as described in the definition of a controlled perimeter. And they are intended to clearly delineate the perimeter and to force potential aggressors to perpetrate an overt act to breach the perimeter rather than being able to cross the perimeter at other than the entry control points without any obstacles. So a controlled perimeter can, it can utilize fences and walls and things like that, but it may also have less formal obstructions, if you will, and the roadways just go in a certain direction. The roadways, the streets lead to the access control point and do not provide an opportunity to run off and try to breach the perimeter at a different location. Parking and roadways themselves, parking lots, parking areas, do not require physical barriers. They only require means to ensure that the boundaries are clearly identified such that driving past that boundary would draw attention. So a parking lot outside of a controlled perimeter does not require physical barriers. The parking lot is beyond the controlled perimeter, and that's going to hopefully and will prevent explosives from being moved inside the controlled perimeter. So a terrorist can park his car in an exterior parking lot and it can have explosives in it, but it is not a matter of concern as far as what we are talking about here, because if the explosive is detonated, it's far enough away that the facility or the building will not be damaged. So, and roadways are the same, that as long as they are outside of the controlled perimeter, vehicles can move around on them, and they can, if this is the way things go, they can have explosives in them. Okay, now authorized vehicle parking. Limitations on parking near buildings apply to all vehicles, including official and tactical vehicles. Tactical could be a military vehicle or a police vehicle or a some kind of a medical emergency vehicle. And so there are limitations on parking all vehicles near buildings, but and that also applies to these official and tactical vehicles, and that's except for emergency vehicles. So emergency vehicles who have been pre-vetted vetted, if you will, and are clearly identified as emergency vehicles, they are authorized to park anywhere around the building. And but other vehicles are not. So the authorized vehicles other than those vehicles are included in the parking limitations in this discussion, because it is assumed that when they are out of the restricted access area, they may be out of the immediate control of their operators, which could make them susceptible to having explosive placed on or inside them. Give me a minute here. Emergency vehicles and command vehicles, that of course is kind of a military term, but it means it's a vehicle that's under the control of a person or persons who have been appropriately vetted, and they are exempted from parking restrictions because they are assumed to be under strict control of a person who has been appropriately vetted, while they are both in and away from their usual parking spaces. Operational support vehicles are exempted because they are assumed to always operate within restricted access areas. An operational support vehicle can be a facilities maintenance truck or something like that. Now, the mobile ground tactical platforms are exempted because they are provided strict security and access control due to the sensitive nature of their missions, and because they must be parked adjacent to buildings to support their connectivity for electronic system updates. What this means is that an emergency or a tactical vehicle, one that is there to defend the building, the facility, is exempt from parking restrictions. So a tactical vehicle of some sort is exempt from all parking restrictions, and that seems logical. Now we move to section 4 here, and we're talking about the levels of protection. And the potential levels of protection are described in tables 2.1 and 2.2, which you will see shortly. These descriptions should be used for a general understanding of the goals of the levels of protection. These standards provide a low level of protection for housing, residential type buildings, and primary gathering buildings like an activity center or something like that, and a very low level of protection for other inhabited buildings. Greater protection is provided for primary gathering buildings, housing, and high occupancy family housing because of the higher concentration of personnel and the more attractive nature of the targets. If the conventional construction standard standoff distances are provided, which you will see later, or if mitigating measures are provided to achieve an equivalent level of protection, and if the threats are no greater than those indicated in tables B1, B2, and D1, which you will see later, the risk of injuries and fatalities will be reduced. Threats higher than those envisioned in tables B1, B2, and D1, which you will see later, will increase the likelihood of injuries and fatalities regardless of the level of protection. Now, let's talk about the applicable explosive weights. And in these cases, only explosive weight 2 is used in the design of windows and doors. And you'll see what that explosive weight 2 is shortly. Where buildings are closer than 200 feet to the controlled perimeter, both explosive weights 1 and 2 need to be analyzed at their actual standoff distances to determine which controls the window and door designs. Where buildings within controlled perimeters are located closer than the conventional construction standoff distances for both explosive weights 1 and 2, they will have differing effects on the various wall types tabulated in table 2, which B2, which you will see shortly. The applicable explosive weights to be used in designing buildings required to comply with these standards are commonly established based on potential bomb locations, with the larger explosive weight 1, required to be applied at controlled perimeters or in parking areas and on roadways where there are no controlled perimeters. The smaller explosive weight 2, and again, you will see what these weights are, applies in parking areas and on roadways within controlled perimeters, in trash containers, and around buildings outside unobstructed spaces. Where buildings within controlled perimeters are distant from the perimeters beyond 200 feet, the effects of an explosive of the size of explosive weight 1 placed at the controlled perimeter will be less than those of an explosive of the size of explosive weight 2 located near the buildings. In those cases, only explosive weight 2 is used in the design of the windows and doors. Where buildings are closer than 200 feet to the controlled perimeter, both explosive weights 1 and 2 need to be analyzed at their actual standoff distances to determine which controls the window and door design. Now, to kind of provide a little bit of clarity, since these explosive weight tables are towards the end of this discussion, basically explosive weight 1 are larger weights and explosive weight 2 are smaller weights. Explosive weights 1 are, generally speaking, what would be carried in a vehicle. Explosive weights 2 are something that could be carried by an individual. Kind of provide a little bit of clarity there. And where the buildings within the controlled perimeters are located closer than the conventional construction standoff distances, which you will see later in some sketches, for both explosive weights 1 and 2, buildings, walls, windows, and doors will have to be evaluated for both explosive weights because the blast effects of the 2 explosive weights will have different effects on the various wall types tabulated in table B2, which you will see shortly. Now, here is Table 2.1, levels of protection for new and existing buildings. Now, this slide is marginally readable in a presentation like this, but if you get a copy of these PowerPoints from PDH source, why this table is quite readable. So you have the levels of protection described in the first column on the left, ranging from very low to high. Column 2, give me a minute to get back to. Column 2 is the potential building damage performance, with the level of protection being very low. As an example, the building damage performance potentially is heavy damage, onset of structural collapse, but progressive collapse unlikely. The term progressive collapse is worth putting a little bit of comment on here. It's a concept that is being integrated into the design of buildings that potentially are targets of terrorist threats. What it means is structurally designing a building not just to withstand the static loads and the seismic loads and the wind loads, but also explosive loads. And essentially what that means is, or a way to visualize this as far as progressive collapse is concerned, if you take an explosive and place it adjacent to a column and detonate it, the column fails. But if the building is sufficiently tied together structurally so that the loads that formerly were resisted by that column are now resisted through some other path, through beams and other columns, and it's sufficient to keep the building from collapsing, then that's what's called designed to prevent progressive collapse of buildings. The loss of a column or a beam is the building will be sufficiently tied together that it will not collapse, so people will be able to get out of the building. So this table 2.1 anyway indicates summarizes the levels of protection and the potential building damage performance and the potential door and glazing hazards, and then the potential injuries are described in the last column. So this will be a useful table for you. Okay, now now moving to talking about standoff distances. Standoff distance just being a distance which is defined as being far enough away that explosives of the assumed weight are going to be kept far enough away that they will not damage the building. So these standoff distances are identified in tables, the ones we've referred to several times, B1, B2, and D1, which are at the end of this slide discussion. And those standoff distances were developed to provide survivable structures for a wide range of conventionally constructed buildings and expeditionary structures. These buildings range from tents and wood-framed buildings all the way up to reinforced concrete buildings. And you will see these standoff distances subsequently here in this discussion. Here now is the standoff is table 2.2, which compares the level of protection for expeditionary structures. These are, again, an expeditionary structure is one that is constructed when a U.S. military organization moves outside the United States to a hostile area. And so the levels of protection are described in column 1. The potential structural damage described in the middle column from severe through minimal, and then the potential injuries that may occur to building occupants. Now, the conventional standoff distances are indicated in tables B1 and B2. They are based on analysis of common conventionally constructed building walls. They do not address framing systems, and they only address roofs to the extent that table B2 includes the least of the applicable wall conventional construction distances at which the roofs in table 2.1 were found not to control any of the standoff distances. The building components upon which the conventional construction standoff distances are indicated. So now trade-offs between standoff distance and associated wall, window, and door construction will have to be analyzed to determine what standoff distances are most economical. So greater standoff distance, in other words, preventing vehicles and people from getting close to a building or buildings, comparing the benefits of a greater standoff distance with the reality that perhaps you cannot control a great standoff distance, and so you have to construct walls, windows, and doors to have greater blast resistance. And these trade-offs need to be analyzed when standoff distances are less than 82 feet. Or explosive weight 1. Again, the explosive weight 1 is the larger explosive weights. You might think of them as being those that would be transported in a vehicle. And 33 feet, the standoff distances are 33 feet for explosive weight 2. These are the explosive weights that could typically be transported by an individual, a person. Wall and roof types in table 2.3 are those that were analyzed to establish the conventional construction standoff distances in tables B1 and B2. These distances may be used as long as the construction for the applicable walls fits within the range of properties in table 2.3. Any construction outside these ranges will need a separate detailed analysis. Okay, I'm looking at my clock here, and I see that we are at 10 minutes before the hour, which is when we should take our first 10-minute break. So let's do that now. Let's take a 10-minute break and come back at about 1 minute after the hour, and we will finish up here. I'll see you all in 10 minutes. Let's see. I'm looking at the chat box. Matthew says your screen is showing all black, not the slides. And Perry says, I am seeing the slides. So, Matthew, I'm going to assume that that you're now seeing the slides. If not, let me know. Now, let's see. There's a question. There are a couple of questions. Local. Okay, Patty asks, local fire, police, or ambulance, depending on who is on the scene first, can assume incident command. Oh, okay, all right, yeah, sure, that's right, Patty. Yeah, uh, this is an operational type thing. Who's a command vehicle? Uh, and then Patty says incident command can change as higher levels of command arrive on the scene. Yeah, understood. Right. You're absolutely right, Patty. Um, so these are the procedural type things, kind of separate and apart from the building design things. Um, okay, again, I'm going to assume that everyone is now able to see the slides. Okay, Will, I'm going to wait another about 3 or 4 minutes, and then we'll start again and continue with the discussion. And from a building design standpoint, the most useful information that you'll get is going to come towards the end when you see um, the representative drawings for standoff distances and so on and so forth. So I'll see you all in about 2 or 3 minutes. Let's see, Matthew says, I still don't see the slides. I'm not able to run from the government computer. From browser, it says I'm viewing Paul Geyer's screen, which is black. I have downloaded the slides and I'm scrolling along with you. Okay, Matthew. Well, it sounds like you've been able to successfully jury rig a way to follow along with the slides. I must confess, this Zoom system that we are using today is one that I don't typically use, and I'm not particularly familiar with its controls and its peculiarities. One of the things that's kind of uh, troubling me today is the fact that for whatever reason it is uh, moving my slides forward uh, and just apparently displaying each slide for a fixed period of time. And that's not the way I typically like to do things. I like to move the slides myself. Okay, well, I guess we can probably go ahead and uh, pick up now and move forward. So let's see. My screen sharing is paused, so I want to resume sharing. Okay, so I'm now sharing slides again, and my goodness gracious, okay, there we go. Uh, let's see, Q&A. Give me a minute while I check Q&A. Okay, I've checked the Q&A. Okay, so standoff distances. How far away from a facility do you want to keep aggressors? And usually, or the biggest consideration probably is vehicular standoff distances, because the vehicles can carry the greater explosive weight. Okay, let's see now. Let's roofs may be assumed not to control the design of buildings for which any of the conventional construction standoff distances are provided, as long as they fall within the range of properties for the concrete and metal roofs in Table 2.3. The least standoff distances at which the roofs in Table 2.3 can be considered to meet the performance requirements of these standards are tabulated at the bottom of B2. Other roof construction or closer standoff distances have to be analyzed separately. And exclusion from Table 2.3 should not be assumed to disqualify that construction from use in buildings. It only means that the construction must be analyzed individually. And once again, the slides are not behaving themselves. And other types of construction other than that shown in this table may be permissible, subject to validation by the designer of record. In a way, what's being said here is that with the type of terrorism threats that have been observed in the past, or the recent past, the roof is not the thing that is is not the thing that's being threatened, like the walls are, and the doors and the windows. So the roofs are a little bit out of the direct line of fire, you might say. Now here is a useful table, a little hard to read or grasp in this computer presentation here, but if, as I say, if you get the PowerPoints from PDH source, this is perfectly readable. And so here you see the wall or roof type identified in column 1, wood studs, steel studs, metal panels, some reinforced concrete, unreinforced masonry, etc., etc. And the assumptions for these sections, the spans, spacing, supports, supported weight, and other structural parameters. So this is the building. These are the building structural parameters that are the basis for the standoff distances described in tables B1 and B2. So if your structural system falls within the umbrella of what's indicated in this table 2.3, then your building is can utilize the standoff distances provided in tables B1 and B2, which you will see later. So continuing on, this slide 26 is just an extension of table 2.3. Now, minimum standoff distances. These standards that we're talking about today allow for the adjustment of standoff distances based on the results of a structural analysis, considering the applicable explosive weights in table B1. The minimum standoff distances represent the distances at which the flexural behavior assumptions of conventional structural design are no longer applicable. At those distances, buildings have to be designed as hardened structures considering breaching behavior. For new buildings, even if such an analysis suggests a standoff distance of less than those in the minimum standoff distance column of table B1, standoff distances less than the minimum standoff distances are not allowed because those distances can be readily accommodated in building and site design. For existing buildings, the standoff distances less than the minimum standoff distances indicated in table B1 will not be allowed except where providing the minimum standoff distance is not possible. In those cases, lesser standoff distances may be allowed where the required level of protection can be shown to be achieved through analysis or can be achieved through building hardening or other mitigating construction or retrofit. These operational options allow for establishing access control for authorized parking at the applicable standoff distances in tables B1 and B2, in which case parking can be allowed to be as close as the minimum standoff distance to buildings without hardening or analysis. The access control in those situations must be established at distances in accordance with tables B1 and B2. Now, of course, the term hardening of a building means additional structural features that you retrofit or incorporate into your building over and above those that are required by conventional building design for static loads, live loads, dead loads, seismic loads, wind loads, that sort of thing. Additional strengthening. The now let's see. I wish these. Stick with me while I. Okay, this is worth commenting on the operational option for existing buildings. And because of the impracticality of moving parking and roadways associated with existing buildings, or applying structural retrofits to harden those buildings may be impractical, operational options are provided for complying with the standoff distance requirements for existing parking and roadways associated with existing buildings. So if in some cases, operational procedures need to take the place of structural considerations when you're talking about existing buildings, because they already exist. And these typical operational options allow, for example, for establishing access control for authorized parking at the applicable standoff distances in tables B1 and B2, which you will see, in which case parking can be allowed to be as close as the minimum standoff distance to buildings without hardening or analysis. The access control in those situations must be established at distances in accordance with tables B1 and B2. The assumption is that by establishing access control into parking areas, there will be lesser opportunities to enter the parking areas with explosives in vehicles. And for roadways, the operational option is to prohibit parking along roadways within the standoff applicable distances of tables B1, B2, and D1. So there are operational options that may be needed when dealing with existing buildings, and just simply you don't have the flexibility to move roadways and other buildings and things like that. So as with procedures at controlled perimeters, the wide variations in the situations for various buildings and installations necessitate leaving the development of specific access control measures, procedural measures, leaving that to local physical security and anti-terrorism personnel. Leave them to the police department or whatever. These operational options will result in increased risk for existing buildings, but acceptance of that risk is necessary to make application of these standards to existing buildings practical. The additional option for allowing parking even closer than the minimum standoff distance, as long as the applicable level of protection is met, is based on the recognition that there may be some buildings, especially in urban areas, where achieving even the minimum standoff distance is not possible. So the short story is that in situations where it's not practical to comply with the standoff distances and the controlled perimeter and the access point, this sort of thing, you have to compensate for that with operational procedures. Now, the standoff distance to the entry control or access control points. Standoff distances from buildings to the entry control or access control point are based on the distances to identification check areas instead of final denial barriers if present, because these standards are predicated on the stationary vehicle bomb tactic as described. With that assumption, measuring to the identification check area is sufficient because that is the furthest point at which unauthorized vehicles can approach. So the standoff distance from the protected building is measured to the identification checkpoint, not the final denial barriers. The final denial barriers are, can be different things, heavy concrete jersey type barriers or zigzag approach, vehicle approach to a building to slow the vehicles down. But the standoff distance to the access control point is that point where identification of individuals takes place. The assumptions inherent in establishing the requirements for unobstructed spaces include the basis for the distance at which they are established and the issue of concealment of explosives within unobstructed spaces and when equipment and enclosures and within equipment and enclosures located within them. Now the distance, the threat upon which the unobstructed space is predicated involves the same explosive weight, weight 2, as that upon which parking and roadway standoff distances within a controlled perimeter and standoff to trash containers are based. Because of that, where buildings are located within controlled perimeters, the unobstructed space is required to extend to the same distance as is provided to parking, roadways, and trash containers. Let me see, I want to get my chat box up here. It seems to have disappeared for some reason. Well, the distance to the outer edge of the unobstructed space is not allowed to be closer to inhabited buildings than the minimum standoff distance, except for existing buildings, as in previous editions of this standard described. The unobstructed space was set at 33 feet without consideration of the effects of bombs of explosive weight 2 on buildings when placed at that distance. Those earlier standards resulted in inconsistent protection between that provided for the unobstructed space and that provided for parking, roadways, and trash containers. With revisions to the conventional construction standoff distances based on building construction, the previous inconsistency has been eliminated in these standards, and the basis for establishing the dimensions of the unobstructed space and the standoff distance to parking, roadways, and trash containers are now the same. The extension of the unobstructed space to the parking and roadway standoff distance does not apply where there is no controlled perimeter, however. The reason for that is that the assumed explosive weight where there is no controlled perimeter, explosive weight 1, is much larger than the hand-carried explosive that is assumed for the unobstructed space. Explosive weight 2, the hand-carried explosive, is therefore the basis for establishing the unobstructed space regardless of the existence of a controlled perimeter. The issue of concealment is predicated on the assumption of hand-carried explosive devices equivalent to explosive weight 2. It's assumed that an explosive device will have a least dimension of 6 inches, which is consistent with a briefcase or satchel-sized object. The requirements for the unobstructed space are based on eliminating any opportunities to conceal objects of that size. It's further assumed that aggressors will not attempt to place explosives where they believe they might be noticed. The key, therefore, to determine what may be located in unobstructed spaces is whether or not a person could see the objects. With that, even if objects are hidden behind constructions, such as large trees, obstructions, such as large trees, those trees would be permissible because the devices could be seen from at least one direction. Concealment establishes the basis for the requirement for above-ground objects or obstructions, indentations in landscape, such as ditches, should also be evaluated with respect to concealment. The requirements related to equipment and enclosures should be evaluated based on similar criteria. Equipment should be evaluated based on the capacity to conceal objects, primarily underneath and inside it. If there are voids within the equipment into which explosives could be inserted, or space underneath it large enough to conceal explosives, that equipment will need to be secured if it is to be within the unobstructed space. For equipment or trash enclosures, the test should be whether or not something could be concealed behind the equipment or trash container. Now some comments on building occupancy levels. Buildings other than residential and family housing can be categorized as low occupancy, inhabited, or primary gathering. Low occupancy portions of buildings can be treated for the purposes of these standards as separate from the inhabited portions subject to specific provision. Buildings that meet the population to be considered a primary gathering building cannot be further separated into primary gathering portions and inhabited portions. The reason for that is that it is assumed that during the life of the building space, utilization changes would result in moving additional people into those areas that are inhabited but do not meet the primary gathering threshold. Only low occupancy portions can be treated separately. Now some comments on expeditionary structures. Again, we know the definition of an expeditionary structure. They are commonly built of either combinations of metal frames and fabric or wood frames and rigid walls. It's assumed that most expeditionary structures cannot be retrofitted or hardened sufficiently for higher threats. Therefore, unless adequate planning is done to obtain the needed space to achieve appropriate standoff, it is unlikely that such structures will be able to be built in compliance with these anti-terrorism standards. Tenant buildings, these are buildings that in a military vernacular are not owned by the US government but by a contractor, but they can be located on government installations. And they are required to comply with these standards because it's assumed that the tenant buildings are likely to be turned over at some point in time during the design life, and that they will then be occupied by government personnel. Again, this is talking in terms of the government facilities, military facilities, which we know why we're emphasizing them. Enhanced use leases are leases of land to other entities like contractors. It's assumed that as long as there is no access to installations to get to the enhanced lease facilities, that there is no increased threat to personnel. So it's further assumed that the type of construction that is likely to be emplaced in enhanced use lease areas is relatively short life cycle construction that would not be suitable for use in the long term. And now the issue of laminated glass and polycarbonate windows. Laminated glass is preferred as the protective layer. This would be the inner light in an insulating glass window. Laminated glass is preferred as the protective layer in glass windows required to meet these standards, because when laminated glass fails, the laminate interlayer tends to retain the glass fragments, significantly reducing the hazardous fragments entering inhabited areas. Monolithic glass and acrylic are not allowed by these standards because those glazings break into hazardous fragments. Polycarbonate or other glazing systems that can be shown to provide the response required by these standards are allowed because they limit fragment hazards. Going in the wrong direction there. Alternate window treatments. These standards do not allow for the use of window treatments such as fragment retention films and blast curtains, where buildings are required to meet these standards. The primary reason for this is the fact that such solutions commonly have much shorter design lives than laminated glass windows, which requires their replacement multiple times as compared to laminated glass windows. Laminated glass, while more expensive initially, is less expensive over its life cycle. Additionally, in the case of blast curtains, there need to be operational procedures to ensure that they remain closed at all times for them to be effective. Film and curtain solutions are good interim solutions where compliance with these standards is not required. Glazed exterior doors are required to be tested in accordance with ASTM F2927 or otherwise have their hazards mitigated in accordance with the appropriate alternative design provisions. When complying with alternative design requirements, the glazing in glazed doors is exempted from the framing and connection provisions of Standard 10 because that alternative allows doors to fail and enter the buildings as long as their hazards are mitigated. Because that is allowed for exterior doors in general, to make the glazing meet all Standard 10 provisions would result in glazed doors effectively being held to a higher performance standard than non-glazed doors. Enforcing the glazing to meet the glazing and frame height provisions of Standard 10, it's likely that the glazing will respond with the remainder of the door panel and that its hazard can be mitigated as an assembly as for non-glazed doors. With regard to exterior conventional doors in previous versions of these standards, conventional doors were only required to open outwards at the conventional construction standoff distances. At those standoff distances, conventional doors tended to rebound off the door frames and fail outwards, resulting in minimal hazards. With the reductions in conventional construction standoff distances, that assumption is no longer valid. So exterior doors are now required to be tested in accordance with ASTM F2247 or F2927, or otherwise have their hazards mitigated. Exterior stairwells and covered or enclosed walkways. Exterior stairwells and covered or enclosed walkways exterior to buildings may be excluded from consideration of inhabited buildings because they generally are not considered to be routinely occupied. An additional consideration with respect to exterior stairwells, even emergency exit stairwells, is that there are commonly multiple such stairwells, and with the explosive weights considered in these standards, it's unlikely that multiple stairwells would be significantly impacted unless they were very close together. Also, stair structures are commonly of robust construction, and even though they do not require compliance glazing, it's likely that they will still be usable even though they are covered with broken glass. Standoff distance, therefore, may be to the walls of the buildings instead of the walls of the exterior stairwells or covered walkways. Now, with regard to exempted buildings, for the reasons discussed below, some building types are exempted from some or all of these standards. The minimum standards should be applied to the exempted building types where possible, however. First, low occupancy family housing, residential buildings. The exemption of family housing with 12 units or fewer in a single building acknowledges that the density of such units is generally low, reducing the likelihood of mass casualties. It also acknowledges the fact that low density housing has rarely been directly targeted by terrorists. The concept of town centers. These facilities have mixed use of low occupancy, family housing, and small-scale retail, health, or community services operations. These small-scale operations are exempted from the standards, and it is assumed that their combination does not significantly increase their attractiveness to terrorists. Gas stations and auto service centers, these facilities are exempted from these standards because by the nature of their operation, cars must be allowed to be in close proximity to them. Other measures included in these standards would be ineffective in the absence of any control on vehicles. In addition, they commonly do not have routine occupancies that meet the standards of inhabited buildings. Temporary buildings, structures, and spaces. These buildings, structures, and spaces may be required for limited durations to maintain operations during construction, for other temporary requirements, or for administering construction contracts. And they are exempt. Lightweight buildings or trailers are frequently provided for these temporary structures, and those kinds of structures are commonly not commercially available with construction such as laminated glass windows that will meet these standards. Enforcing the standards on these structures, therefore, would be of questionable economic feasibility for the short duration for which they are anticipated to be used. Standalone, franchised food operations, mini marts, etc., McDonald's, things like that. These facilities are exempted from the standoff distances for parking and roadway provisions because by the very nature of their smaller size and their operations, they require parking in close proximity, and applying other upgrades required by these standards is feasible and will lessen the risk of mass casualties. Let's see, Hank, stick with me for a minute. I'm checking. Let's see. Perry has a comment. You say roofs are out of the line of fire. They are subject to overpressure and could be a point of failure. Well, yes, that's certainly true. However, that's the way these standards are written, is that the primary concern is the walls, windows, and doors. And the but that's a Perry. That's a perfectly valid comment. Okay, getting back on what I'm doing here. Now, policies and procedures. Again, the question of anti-terrorism mitigation is a combination of what you can do as far as building design and planning of the facilities and this sort of thing. But there are, right along with those facility type measures, are operational measures. And these fall into the province, of course, of the law enforcement agencies or the security forces or whatever. So but these administrative procedures are critical, and it's assumed that there are means to control access to controlled perimeters. That's an administrative procedure. Stop the car, search it, that sort of thing. Underground parking, access control point at an underground parking garage where vehicles can be inspected if appropriate, and other areas where vehicle access needs to be limited. And it is assumed here that there will be sufficient access controls to preclude explosives and chemical, biological, and radiological agents from being introduced into inhabited building interiors. So the administrative procedures, searching visitors, is the primary line of defense against these kinds of threats, chemical, biological, and radiological, and as well as explosives. And it is assumed that the provisions of these standards will be coordinated with all other applicable building and design criteria and policies, building codes, et cetera, Nothing in these standards should be interpreted to supersede the provisions of any other applicable building or design criteria. Where other criteria mandate more stringent requirements, it's assumed that the provisions of these criteria will be followed. And it is assumed that key security and facility personnel will receive training in security engineering, anti-terrorism, physical security. It's further assumed that all persons have been appropriately trained in basic anti-terrorism awareness, attentiveness to packages that are left unattended. Okay, now we get to the the standoff to tables B1, B2, and D, and the standoff distances for new and existing buildings. The distances to the controlled perimeter to park, I wish these slides would stop jumping around. So the distances from the building to the controlled perimeter or parking and roadways, the distance between parking and roadways within a controlled perimeter, and then distance to trash containers, because they, of course, are frequently used to conceal hand-carried explosives. The building categories, residential, primary gathering, and inhabited, and the applicable levels of protection, the construction, conventional construction, standoff distances for load-bearing walls, non-load-bearing walls, and minimum standoff distances, and then the applicable explosive weights, 1 and 2. 1 being primarily vehicle transported, and 2 being the smaller ones that an individual could carry. Now, the previous table here, let me get it up here. This table characterizes the standoff distances with these letter designations A, B, C, D, but those are explained then in table B2, where with the different conventional wall types, wood studs, steel studs, metal panels, etc., reinforced concrete. And the without a controlled perimeter, the applicable explosive weights, the load-bearing and non-load-bearing walls without controlled perimeter, and within a controlled perimeter. Without a controlled perimeter means outside the controlled perimeter. Within means inside the controlled perimeter. So that's table B2 is the conventional construction standoff distances, and you can review those at your leisure. Okay, now we get some a little better picture of what we're talking about as far as the distances involved. And this figure B1 is standoff distances with a controlled perimeter. And the standoff distances, gosh, this is driving me cuckoo with these slides. So you can review this at your leisure, but this kind of distills a lot of these words that we've been using today down to graphics that are we're better at probably at grasping as engineers and architects. So standoff distances, figure B1 with a controlled perimeter. Now here are standoff distances illustrated with no controlled perimeter. Because of the nature of where your building or buildings are located, you can't have a controlled perimeter. And now figure B3, parking and roadway control for existing buildings with a controlled perimeter. And you can review this at your leisure. Figure B4, parking and roadway control for existing buildings with no controlled perimeter. Figure D1 is standoff and illustrates standoff and separation distances for groups of residential structures. And that, as luck would have it, brings us to the end of our allotted time. And so I hope this gave you a broad brush picture of these anti-terrorism standards, the concept of controlled perimeter, it's either there or it isn't there, access control point, it's either there or not there, standoff distances, and the concept of the explosive weights. The group one are the ones that would typically be carried by a vehicle. Group two would be personally carried explosives. And then we finally got down to the seeing in the more understandable graphic form the standoff distances. So this has been a very brief and unfortunately not a particularly easy presentation to grasp, and I really apologize for these crazy slides because there's something that has been automatically moving my slides without me doing it, and I'm going to have to try and find out what that is. So anyway, we are here at the end of our time. I hope you got a little bit out of this, and you'll probably get a lot more out of it by going back and reviewing these PowerPoints at your own rate of time availability. With that, let me just thank you very much for letting me chat with you today, and wish you to all have a nice rest of the day, and I'm going to close things out here. So thanks a lot. Bye.